Ever feel like your VR project is moving slower than a snail on a coffee break? Then this video is for you. Whether you're building for a standalone or PCVR, I'll show you how to take your Unreal Engine VR game from meh to chef's kiss smooth. We'll break down simple, practical strategies that actually boost performance, no fluff. So let's dive in before that snail finishes its coffee. Okay, before we start the tutorial, I have to mention there is an article, there is a companion article to this video, which right now you are seeing on the screen. I haven't yet published this, but I'm going to publish it on my blog once this tutorial is fully recorded. I will put a link to this article in the description of the video. Whatever I'm going to describe in this video is already described in detail inside this article, so that's why we are using it as a reference here. Also, I have to put a disclaimer here. By no means this is a complete guide. This is my best practices, or basically these are my guidelines for optimizing an Unreal Engine project. This is what I do when I want to optimize a Unreal Engine project. I start from here, and then of course there are many more things that I will do usually, but this is basically something for people who don't have any idea about optimization and they want to quickly optimize their project as much as they can. Of course, for example, if your assets are not optimized, this is not going to make much difference for you, or your code is not optimized, or whatever you are doing in your project. There could be other bottlenecks, but yeah, this is like a general guideline you could apply to any project. And as I said, this is my approach. You could find other information probably from other sources, or even Epic's documentation, Unreal Engine documentation, in addition to this. So now we got that out of the way, let's take a look at the article. Of course, there's a table of content. You see some information here inside the table of content. The first thing I want to show you actually is like some time ago, maybe a year ago or something, exactly a year ago, I basically tweeted this. This is a project of mine. We are going to actually work with this project. In this project, as you can see, I'm getting like at least 120 plus FPS consistently without even relying on DLSS, like frame generation technology. And this is just purely with Unreal Engine. When I started this project, I was getting like 60 FPS or something like that. And then I started optimizing it. And yeah, this is basically what I was going to get. And you see here, I have like, for example, these flags, class simulation, but of course I have to fix this because this was done in an older version of the engine. I just upgraded and I didn't care about it. But on the walls, for example, you see 4K videos are playing, and there are good lightings here, and also shaders, and basically, yeah, everything you could find inside this scene, and it's well optimized. Of course, it could be more than this, but yeah, basically this was my project. I doubled the FPS with ease, and also this was basically the mobile like a standard sorry, PCVR, and now this is like a mobile or a standalone. As you can see, this is running on Android, not Windows. The other one was running on Windows, but even on Android I was able to get like 40 to 70 frames per second on a Quest 2. This is not even Quest 3, which is of course more powerful. So this is the proof of what basically you can do. And also, even when I introduce DLSS inside this scene, there's another video. You see this basically widget comes with the DLSS plugin from NVIDIA. I can do even better, and I can do a lot of other things, which I show basically in this video. But anyways, these are, we are going to go through this, but yeah, this is a sample for you to see. Of course, if you have an Unreal Engine project, you want to convert it to VR, because what I'm going to show you here is mostly focused on VR. For non-VR projects, some of these of course apply, but we are here focusing solely on VR, and basically we want to optimized for VR. I'm running the project to show you something, because if you don't have a project, and it's basically, if you have a project, you want to convert it to VR, you have to go to settings. Inside the project setting, you go to the description, and there you check this box, start in VR. Then your project is going to run in VR mode. But probably it takes a bit of time for this to initialize. And of course here, I'm getting really good FPS because I've stripped down this version of the engine. If you take a look at the source code for this project, my project sits inside the engine. I've basically forked the Unreal Engine and I put my project there. You can do that easily. Like even if you modify this file, you make your project like folder part of the engine build process. So they're kind of coupled together. And then, yeah, and because of that, it even takes less time to build the engine from source, because I've disabled a lot of stuff that I don't need. And yeah, this is my own fork of Unreal Engine I maintain, with some modifications, of course, as well. But anyways, as I've mentioned, if you go to the project setting, to the description, and here starting VR should be checked. But anyway, I've already did package this project for Windows. Here, as you can see, with the default render and with the forward render, which are two kind of renders that we are going to basically experiment with. I'm going to put on my headset here, because I want to first show you the first tip. The first tip is usually when you run your MetaQuest project in PCVR mode, which means you stream from your PC. We are usually using two modes. One of them is PCVR, or they call it a streaming mode. You stream from your PC to your headset using either Wi-Fi or the Quest Link cable. Here, as you can see, it just recognizes my headset. And then when I do that, I have to also run the Quest Link on the headset. Sometimes it takes time, or it's not gonna work. You have to kill the process on Windows, or reboot your Windows computer, or reboot your headset for it to work. And right now, yeah, it's running. So yeah, and here it turned to active. It shows the battery, which means it is connected. So I was yeah, talking about the difference between PCVR, which is this one. Of course, in PCVR, you usually get a better quality because it runs on your PC and then stream to your headset. That's why you can get away with a lot of things. But when you run in a standalone mode, it solely runs on your headset as an APK on Android. So that's why you have less resources, less computing power, and yeah, you have to compromise a lot. But anyway, right now, let me run this out of the, I'm not going to run it from the editor. I'm going to, for example, run the deferred one from here. And probably it will open up on my first monitor, which, yes, half of it is my on my second monitor. That's why I have to maybe make this windowed. And okay, we got it in window mode. Now, well, yes. Let me make this full screen. don't know what happened. I believe I have to close this by force, Alt F4, or even maybe kill it. So let's run it from the editor. I guess it would be much better probably, or maybe we try it one more time. Let's run it from the editor. I believe it would be easier because we are using PCVR. Something is not working and I don't want to fix it right now. So okay, now let's go to VR preview, which is going to run it on the VR headset. Yeah, as you can see, I already see some frame rates here, and it runs at like 72, 73, as you can see here. And yeah, I could, for example, walk around, and even from here, from distance, when I look, it's 72, and when I go here, it's 72. As you can see, it seems kind of like our FPS is locked. I could, for example, run a console command, like it's called tmax FPS. And it says when you enter something smaller than 0 or equal to 0, like -1, it should be unlocked. But when I do that, nothing happens. As you can see, it's just 72, 73. So what's the problem? Despite the fact that we did unlock the FPS, as you can see here, I don't get it. The problem is, as I've mentioned inside the article, not here, here, because the reason is Quest 3 by default, like this is from the original Quest, Quest 1 basically, but of course the name was Quest. They locked the FPS to 72 hertz. That's why all the basically quests after that, like Quest 2 or Quest 3 by default, they use 72 frames per second. Their refresh rate is locked at that. So if you want to change that, you go to basically your device settings here, and it's not here. Why I cannot use it? Okay, because I have to stop the... I already did stop it. Maybe I have to quit Quest Link. I will quit it on my headset and put down the headset. Okay. Yes, I had to basically quit from the other side. Then here you see the refresh rate. It says it's 72 hertz and with this resolution. And if I come here, of course I can. They say this is the recommended one, but of course I want more FPS. That's why I go with 120 hertz. And once I go there, the resolution is going to actually decrease, which is also better because I'm gonna get more FPS out of it. But of course, if you care about quality, like the pixel density, you have to go for a for less refresh rate. But here I care more about FPS. That's why I'm gonna do that. It just closes the MetaQuest app, and then after that, it takes some time to reboot. It's now the splash screen for it is on my first monitor. Then yeah, it just appeared again. And this time, if I check it here, yeah, it says 120 hertz. And now let's try to see if we can get 120 hertz for sure. Unfortunately, Unreal Engine crashed. This is a known bug. So I'm going to resume it, but no, it does not work. So I have to close the engine and probably rerun it. Sometimes this happens. Okay, now I'm going to VR preview. Let's see what do we have here. Of course, I'm in the cinematic, and as you can see here, I can get easily 120 hertz FPS. And of course, I can switch between these profiles. As you can see, it takes a bit of time to just adjust. But anyway, no matter where I go, like in cinematic profile or low or high, it's 120 hertz I can get from this consistently. So this was the first tip and trick to get basically more FPS when you are doing PCVR. So I'm going to exit. Perfect. Now into the next part of the video, we are focusing on standalone mode or mobile when you deploy to your Quest headset. The early versions of Unreal Engine 5, it was not basically optimized in terms of rendering. Technically on Unreal Engine version 4.27, it was always in my test outperforming Unreal Engine 5. With Unreal Engine 5.4, things changed significantly. They revamped their rendering pipeline in a way that things got faster, like 50% at least. And it was improved in general, the rendering in Unreal Engine 5 significantly. Then with Unreal Engine 5.5 and 5.6, they focused on bringing a lot of rendering improvements to mobile, and their mobile stack, yeah, I would say it just improved significantly, not just in terms of performance, but also in terms of features. They added a lot of feature to the forward rendering, which is their default mobile renderer in Unreal Engine. I did put those relevant sections from the changelog of Unreal Engine 5.5 and 5.6 for you here. You can also click on these links and go read the whole changelog or release notes. But anyway, as you can see, most of these changes were relevant to mobile renderer, the rendering changes. So that's why I did list them in here for you to see what has changed. But anyways, here, there are some settings which inside the engine you can change, like a checkbox or something, and those changes sometimes do magic. Like without doing much, you get much better performance. That's why it's always good to know what these basically settings do and what is the reason, or what's the basically what's the reason behind it that you must, for example, disable or enable something. For this, you have to go to Edit, Project Settings, and once you are here, you can usually either go, for example, if you want to change a rendering setting, you go to the rendering section, then you find that, and then also if you hold your mouse here, you will get a brief description of what these for example settings do, or you can just like search them straightforward from this search bar. But anyways, let's go back to the article. The first setting is forward shading. As I've mentioned, Unreal Engine comes with two renderers. One is forward renderer, the other one is deferred. Deferred usually yields a better quality. On desktop, I highly recommend use the deferred renderer. But on mobile, yeah, I highly recommend to go with the forward render as it is the recommended one. But anyways, if you open this image here, you can see the first one is forward shading. If you enable this, basically it's going to enable forward render inside the engine. Even in desktop, it's going to use the forward renderer. The other one is this one, which is for mobile. It's called mobile shading. You can put it either on forward shading or deferred, basically shading. As you can see here, I have the mobile shading here, and I can choose either deferred or forward shading. And when I change that, usually the engine asks me if I want to restart the editor, for example, for you to see it. It asks me I have to close the engine for this settings to take effect, but I'm gonna change it to forward shading, and yeah. Also, I can type here, for example, forward. As you can see, it just brings both of these for me and just find them rather than me going through this and find them one by one. But anyways, so let's go back then. The first one was forward shading. We usually changing this, you will get significant improvement, but of course it might break your project because there are some things that are only supported in the deferred renderer and not forward render. But of course, forward rendering is catching up. As we saw in the release notes for Unreal Engine 5.5 and 5.6, they added a lot of new features to it. But anyway, the other one is mobile HDR. I also recommend to disable mobile HDR, as it could be heavy. As you can see here, I have it enabled, but yeah, if I'm going to deploy to Quest, it's better to disable it. And even for this, because most of these rendering settings, when you change them, it's going to ask you to yeah, do you want to reboot it or not? So we can just apply the settings and reboot all sorry, all at once. The other one is instant stereo, which is basically this one is also recommended to do. The reason is basically you render two images on each eye on a VR headset, but they only change basically this images, the difference between those is like really not significant. So if you enable this, it's going to streamline your rendering, and it just reduces the VR workload, so less power is required, computing power. Instance stereo. So as you can see, it's enabled for me. Also, the other one is mobile multi-view. Again, I recommend to enable this one, especially if you are using these headsets, which are a bit old. Mobile stereo, multi-view, I guess. Multi-view, yes, it's enabled. So the other one is mobile anti-aliasing method. If you mobile anti-aliasing method, I could, for example, use MSAA, which is the recommended one here. Also, yeah, you could choose FXAA, which is much faster, but of course, the other one is smoother and yields a better quality, this MSAA. Then the other one is reflection capture, which reflection capture, I recommend to reduce this either to 128 or 200, basically 56. And then the other one is texture settings. Also, there is something called virtual texture. Again, I recommend to disable this. I cannot disable this because I use it in this project. That's why I have it enabled. But if you are not using this inside your project, you have to, if you disable it, it's going to improve the performance. Of course, I did put the link to the documentation, and you could read more on this. What does it do? And then get familiarize yourself with it if you don't know what is that. Also, texture streaming, same here. Again, the documentation. You have to enable this because it's going to help basically by streaming the texture and loading them progressively. It just reduces the memory footprint. Also, the texture quality, you can adjust those to medium or low depending on the capabilities of your target hardware. Then there's the texture compression. I highly recommend also to use Android ATSC. If you package here, you see it. To package with Android ATSC. And yeah, of course, this is particularly depends on the device as well. Some devices might not even support this. You could go with the multi-device profile, but in general, yeah, for Quest headsets, for example, or HTC VIVE, ATSC is okay. Then the lighting settings, I highly recommend again to use static lighting. For example, if you check the lights in my scene, here I'm always using static or stationary lights rather than movable, because those movable lights are really costly. Also, I don't use lumen because lumen is still, I believe it's not there. I prefer to basically bake my lights. Of course, I have to build the lights in advance, but yeah, with GPU Light Mask plugin, yeah, you could significantly reduce the time that you are building lights or baking lights. And yeah, I just bake it and that's it. It's going to yield the best performance, and the quality and the lighting is really good. Then the light map resolution, you have to also, it is recommended to lower these if you are targeting a mobile device. Then dynamic shadows, you could use, for example, cascaded shadow maps for improved performance. And then there's the distant field shadows or ambient occlusion. Also, it is recommended to, I just closed it, ambient occlusion. This is recommended to basically be removed. Anyway, and then there are post-process settings, for example, like bloom, lens flare, or auto exposure. These are related to post-processing and camera. So, for example, bloom. It is like recommended to disable this, to minimize this, or don't use it. Here I use it because I don't have any problem with it. Also, there's the other one. Yeah, you can see here, rather than me searching for them one by one. This one is lens flare, and the other one is auto exposure. Which I recommend to disable if you are, I mean, experiment with these. Of course, some of them might not even affect you much. The other one is a screen space reflections. Turn this off, and also motion blur. This one is really costly. Motion blur, it is recommended to just disable it. And then, of course, we have materials and shaders. Try to reduce your materials complexity. For example, if you have I don't know, material here, these materials usually come with nodes. Some of them might have, for example, hundreds of nodes here, like it's a complex material. Try to reduce these as much as possible. Also, some techniques you could use to, for example, emulate costly nodes that you have here. These are really specific. I cannot go through these, and I'm not, of course, I don't know much about, in general, materials, how to do them in Unreal Engine. I only know the basics, but anyway. Specular highlights, also reduce or disable this. And the LODs also ensure basically you have LODs, and it's just going to help you a lot. And then the level of detail settings, also mesh LODs, basically reduce the polygons as objects move farther away. Of course, these are the basics that you probably know. And then the screen size, and then also, yeah, one other thing is engine scalability settings, which basically It is recommended to decrease the resolution scale, for example, to 70% or 80% to get a balance between quality and performance. For example, here, if I go to the, let's run it here. If I go to low, you see the quality is really, it's not that great. I mean, you can immediately see it, even like between low and medium. And also, for example, you go from low to like cinematic, you see the difference? It's just like too much. And then, yeah, basically, yeah, if you go to Epic, for example, Epic is the default in Unreal Engine. It's like around, you get 70-80% of the quality, and these are here, like 80% of the quality, but of course, it significantly improves performance. Then the view distance, basically, these are here. You can adjust these separately or inside these profiles, because Epic provides this profile for you to quickly change all of these like immediately. Or you could go auto. It's gonna use benchmarking to determine what is suitable for your PC, which in this case for me, Epic is the recommended one on this PC. But also, let's go back. Yeah, for all of these, yeah, there are some recommendations here you can follow. I'm gonna skip them. And here also in PCVR, as I said, the default is Epic, but on Android, when you run on Android, you have a custom profile. The Epic games, they don't use these profiles. They have a custom profile by default on Android. You could use that one. And as you saw in the initial video that I showed you at the beginning, I was using the custom profile on Android, and I was getting like between 40 to 70 frames per second. Anyways, also, we have some guide here in regards to this. We will talk about it in details. Then for physics and collision, of course, physics simulation, try to reduce the physics simulations, limit them on mobile. And also for complex collisions, I highly recommend to reduce your collisions to basically basic collisions rather than the complex ones. Also for audio settings, this also depends on the audio engine you are using, but for example, you could use Wise, Fmod, or what is provided by Unreal Engine. But of course, in general, try to reduce the number of channel and sample rates is going to help you as well. Then the rendering API, whether choosing between Vulkan and OpenGL ES, of course, this is device dependent as well. But nowadays, like most people, they use Vulkan. It is well supported, especially with the recent versions of the engine. And yeah, you could also switch to OpenGL ES as well, if your hardware supports it, and you could get a better performance. But yeah, in general, Vulkan is really good. I mean, yeah. So, and then the calling. What is calling? Basically, in Unreal Engine provides different kinds of calling. Calling is, if I want to give you like what calling is, because there are like several different things. As you can see, you have a view frustum here inside the, like there's a plane here at the end, and there's a plane here on your camera, which is the camera lens, and this is like the far distance that it could see, and this is basically what you see on your screen when you are playing the game, and you are not seeing anything outside this basically a square or clip. Then anything outside that, Unreal Engine uses calling to determine whether those things are rendered or not. For example, if you are seeing here, all the other objects outside are not being rendered. But of course, for example, if you see an object partially, that object, although you see it partially, it's still getting rendered. Even like if you see 1 pixel of that object, it's still getting rendered. So, but of course, as I said, Unreal Engine has different kinds of calling. For example, distance calling, view frustum calling, pre-computed visibility calling. I'm not going to go through them because otherwise the video is going to get too long. And then dynamic occlusion calling, and yeah, there are like different kind of these, and also hardware occlusion queries is the settings that you directly can use to control some of these. And just one thing I have to mention is basically some of these you cannot disable, some of these you have still control over to basically enable, either per actor or, for example, globally. But anyways, then the hardware occlusion queries, these are enabled by default and supported, for example, by OpenGL or Vulkan. Then you can control these settings. For example, if you go to project settings here, this is for occlusion calling. You can enable or disable it. Then inside project settings, rendering, some of these also, of course, you like there are various places you could control these settings. For example, some of them you can control through the project setting. The other one could be through either command line, like the console command, sorry, not command line. The console commands inside the engine, for example, here when you press the tilt button, if you are playing the game, you press the tilt button and then you start typing, you could control those settings. Or some of them you could basically modify through the INI files, like if you go to your project here, dev, for example, config, you could basically override these settings from these INI files. And if you open these, like there are various settings that you could do. But yeah, these are all explained here. You could enable, disable these if you want. And there are some console commands as well. These are actually interesting. Let's see them in action. For example, one is called stat init views. If you type stat init views and press tab, it's going to complete it for you. As you can see here, you see some statistics, for example, the frustum called primitives, the average, max, mean, like, yeah, you get some stats here, and the frame rates, for example, spent on some of these. And yeah, you could use this to basically assess your scene using this. But anyway, and the number of call counts these basically use. But anyway, again, if I enter it, it's going to toggle it. The other one is freeze rendering. This one is interesting. Let me put on my VR headset. And I have to, I guess, wait again for this to recognize the QuestLink app. I have to stop it, then I go to VR preview. And the next command we are going to basically do is called freeze rendering. Then the other one is R visualize occult primitives. But let's see first this one. Okay, now I'm inside the scene, as you can see here, and when I look around, you see I see objects behind me, or objects, for example, on the right or on the left or whatever. Then if I come here, for example, I look at here and then I enter freeze rendering and just press enter. Okay. Now look at here. As you can see, it just froze rendering whatever it was rendering. And if I look back, I don't see all those objects because they were not inside the field of view of the camera. So if I look back, none of them are rendered. So this is how Unreal Engine basically keeps up the performance. They are not going to, these are the tricks they use. Yeah, this is basically calling. I mean, there's no better way to explain it. So anything you don't see, it's not going to be rendered. And as you can see, you have only whatever you see inside your field of view. For example, when I was taking a look at this wall, because the other wall here with the news on it, it was still visible, it's still render, or yeah, or the other objects that you are still seeing the scene. And here, if I enter again freeze rendering, it's going to toggle it, and now I can still see everything. So yeah, and let's, for example, I can do this, for example, look at the other side. And once I am back, you see some of these objects are gone because they are not visible. But anyway, for example, you might say, oh, why this table is visible? Because Unreal Engine determines whether this should go or not. If I look at, for example, at my feet, probably this is part of this floor. That's why it is rendered. But anyway, so this was freeze rendering. The other one was R visualize occult primitives. Okay, I have to basically enter a parameter. One means true, enable. I'm going to do it. As you can see, these are basically these primitives are the ones that shows, for example, if I'm looking at anywhere outside inside this boundary, that object is rendered. If I don't see any of the any part of that boundary, then that object is not going to be rendered. That's basically what it does. It's going to visualize for you what is visible, what is not visible. It's good, for example, if you have a massive object, you want to break it down because yeah, there are lots of polygons or whatever inside it, so you want to break it down maybe. Then yeah, you see. Okay. Yeah, these are some tools for you that you could use to work with Occlusion, with calling, sorry. So, well, now besides what Unreal Engine provides out of the box, we could take additional optimization measures, which depend on the kind of device that you have. For example, if you are using a Meta Quest headset or HTC, for example, VIVE headset, you could take different optimization measures. Like, for example, let's go start with the MetaXR. For MetaXR, there is an Unreal Engine plugin. Even if you are not going to actively use it in your project, you could just download it, apply the recommended settings, and then remove it or disable it inside your projects. For this, you have to come here and then download it from here, and then follow these instructions to install it. Once you install it and reboot the Unreal Editor with your project, you will get this toolbar here, and from here you could go to MetaXR project setup tool. Of course, if you don't see that, you have to go to edit plugins and here look up MetaXR, as you can see. And then after that, you will get this bar here. So from here, you run this MetaXR project setup tool. And if you come here, it's going to show you, for example, it says if you are using PC streaming, PCVR, or if you are going to run, for example, a standalone on Quest 2, Quest Pro, or Quest 3, Quest Pro, or Quest 2. Then there are a few sections, like, for example, required rules, recommended rules, or applied rules, or ignored rules even. What I can do quickly, just click on apply all, or I can go through them and do it one by one. For example, here I do apply all and it says, do you want to restart? And as you can see, it's just for all of them, it's clear. I'm going to restart, but in the meanwhile, until the engine comes up. For example, the first time I run it, because I already did basically apply this to my project. You see here, for example, there are some settings that it says these are required. You have to do them. The other ones are just recommended, and these are the ones that are good actually already. So like, as you can see here, any tab that I go, there are plenty of like these that could actually improve the performance. Yeah, for example, I already mentioned some of those, like PC forward shading, instance stereo, start in VR, whatever, or MSAA, or yeah, whatever else that is here. But anyway, the engine is, I guess, up again. And yeah, sometimes you have to apply this multiple times. For some reason, it's not going to be applied the first time you do it. That's good to just always, after your engine is back again, back up again, you could come here and always check if you have the optimal settings. So yeah, this was a quick way to basically improve the performance and apply the optimal settings to Quest headsets. Then for Quest headsets, basically also there are some other things. These are not like only Quest related, but also could relate to any other headset. But for some reason I did put it here. I don't know. Maybe I did put it in a separate section, or I did put it under this, but I have to fix this then. Anyway, the other thing that you would like to maybe enable, call fixed foveated rendering, or FFR. I think if OpenXR plugin is enabled, I don't know if I have it. Even it just provides that. Maybe OpenXR settings. Yeah, you see, even the for MetaXR, I have this foveation extension which I can enable, and here it says like this one is going to enable foveation. But let's see what foveation is. Basically here, and also if you have this thing called HTC, which also you can download from here. But of course I don't have it because they promised to release the Unreal Engine 5.5, but they didn't, so that's why I don't have it here. Also, I don't use HTC for my own personal projects, although I do use it at work. But anyway, here I believe there are some settings related to that as well. Maybe not, I don't remember. But yeah, you can go through the setting and find it, or search Google for the documentation on it, and or probably they use this one from the OpenXR plugin. I'm not sure, but you can always look it up. But anyway, let's go back to what FTR is. Okay, fixed foveated rendering, which is basically a technique inside VR or AR application. They are going to only render like high quality with all the pixel and everything, like the center of the screen, and the peripheral area, which is like the corners. They are not going to like render it fully at full resolution. They do render it at a lower resolution than the area, which is probably the users mostly focus on, is the center of the screen. They render that area at like full resolution with full quality. This is going to basically reduce the load on the GPU, and that's why it's going to improve the performance. Devices that support this are including include MetaQuest 2, MetaQuest Pro, and MetaQuest 3, and also tethered headset like HTC VIVE and Valve Index. If they are paired with a compatible GPU, they could do this. But also there's another technique which is more advanced, but of course it's not going to work on any headset or every headset, called ETFR. This one requires basically dedicated eye tracking hardware. That's why only, for example, headsets like MetaQuest Pro, PlayStation VR 2, and Varjo Aero or HTC VIVE Pro Eye support it. Other headsets like MetaQuest 2 or MetaQuest 3, they don't have this basically, but Quest Pro has it, of course. Then what it does is basically, if you look at this video here, this GIF, the user, everywhere the user looks at, it's going to be rendered at high quality, and the other places which the user is not focusing on are going to render at a lower quality. So that's why this one is significantly going to reduce the GPU workload, and it could significantly improve performance. But of course, unfortunately, most consumer devices, they don't have it. Yeah, it's mostly for those applications or people like industrial settings. They need the highest possible graphics quality. They use headset with this eye tracking hardware that enables them to use ETFR. That's also one thing to have in mind if you are such a user and you have access to such hardware. But anyway, the other one, of course, is HTC VIVE OpenXR plugin. As I've mentioned, unfortunately, it's not at the moment supporting Unreal Engine 5.5. It only supports at the moment 5.3 and 5.4. But with this one, also you could do some things in Blueprint, and also, of course, with the settings. For example, what you could do is to set a pixel density, because usually these headsets have a higher resolution. But if you wanted, for example, to match Quest 2's resolution, you could call this function, set a custom, set custom pixel density or something like that. Yeah, you could do it with this console command, VR pixel density. You run it and this and put it basically on 0.8. And then once you do that, it matches the Quest 2 and improves, of course, the performance. Then you could also lower the refresh rate on the device itself, like on Android. For example, by default, I believe it's set to 90. Then you could read it actually, or enumerate even the available ones using these three commands. When you use this one, it usually returns 75 and 90 hertz. Then with this one, you could get the current one that is in use, get display refresh rate, and also with the request display rate refresh rate, you could request a new refresh rate. But in order to be able to use this, you have to enable this extension, which is an OpenXR extension, by enabling this one inside the settings. If you go to project setting, Vive OpenXR, and you have the plugin, of course, I don't have it. That's why I cannot see it. But here, if you enable this, you will reboot your, it asks you to restart your editor, and then after that, it is available. Then, of course, like this, for example, you could add your event begin panel play. You could enumerate them and also print them if you want to, or you could print the current one, or you could, for example, using this one, request display refresh rate. If it's returned true, that means it was able to successfully set it. Otherwise, it has failed. And of course, you could always read it with this get display refresh rate. But anyway, yeah, I already mentioned this 90 hertz, 75 hertz. And anyways, if none of these is going to help you and you still get a low refresh rate, you could try and go to your project's default, I guess inside config here, inside your project setting, inside config and default engine INI. If you open this, and then here, basically you have a section, I believe rendering or something. Yes, engine rendering settings. And then I have to find it here. Yes. And I could add all those, copy them and add them here underneath all these other settings. It is going, of course, you could remove the duplicate ones. These are all settings that you could tweak. You could play with them one by one to see what do they do. Of course, there's a lot of them, but this is the optimal settings that I usually use in my own projects I came up with and then I use. So yeah, that's something that you could use. And then now to the next section. Okay, the other one is game user settings and engine scalability settings. These are features of the Unreal Engine. As I've mentioned already, there's something called engine scalability settings with some profiles: low, medium, high, epic, cinematic. If you go here, like here, of course, if you set them here, for example, you set them on medium, then you go inside the game, it should be, oops, we crashed. Probably it was because of MetaXR plugin, because I wanted to enable it. Then let's go back here. I'm going to maybe here. Let's search for MetaXR. Meta, or maybe it is Oculus, I believe. Yes. It says disabled. Maybe it's this one. Okay, I have to wait for it for a bit, but anyway, we have to wait a bit. But what I could do actually, go to my engine, plugins, engine, marketplace, and I'm going to just remove this MetaXR folder altogether. So now I should be able to actually run this because I don't need it. But anyways, okay, it's going to take a bit for this to load, but in the meanwhile, so as I was saying, basically you here have like engine scalability settings. Changing these either inside the game or either inside the engine is going to affect basically each other. For example, if you do plane editor, right now it's on cinematic because probably at the beginning of my level inside Blueprint, what I do is at event begin play, I set it here. Whether it's Windows or Linux, I do some things here. I'm going to save this for now, disable it. Let's go to the selected viewport. It's now on cinematic, and I binded my keys on the keyboard. For example, if I press 1, it switches to low. And if I end the game, I come back here inside the engine scalability, it's on low. But for example, let's say I'm going to put it on medium here, and then I'm going to run the game. Immediately, my game should be able to pick it up, which is weird. It didn't, but I usually seen that. For example, let's set it to high. Maybe the code I wrote here is broken. That's why it's not showing it, because yeah, you see when I set it to high, here inside my engine, it's going to set it to high. Or for example, if I set it to cinematic, let's run it one more time, press 5. This should be cinematic. Yeah, I mean, it should be two-way, but probably, yeah, my code is broken, or it might be something else going wrong. Apologies. But anyway, the thing is, like with this one, even you could like set these like this, for example, and then it will be like it should show custom, but here it does not show it. But anyway. Also, you could run a benchmark. For example, if I press 0 on my keyboard, I wrote the blueprint for it to run a benchmark like the auto, and it determined like epic is the one that I should be using because it's the most suitable for my hardware. And it's exactly similar to this functionality here. When you press auto, it's going to run a benchmark, and as you can see, it just determined it by basically running a benchmark. If I go to level blueprint here, as you can see, when I press 0, it sets it, for example, to auto, which is like benchmark in my case. Then low, medium, for example, if I press 3, it will be high, 4 will be epic, and 5 will be cinematic. But anyway, How did I do that? I wrote here in this project, I wrote C++ to do that. Basically, these are my nodes, like set engine scalability setting accepts my own parameters. But you could, of course, do this in Blueprint as well. There's a function called set overall scalability level. If you call this, it accepts like a parameter, or also you could get it. The thing is, let's close all this, get them out of the way. The thing is, if it returns -1, that means it's set to custom, which means like the user, I don't know, for example, they put this one on medium, this one on low, this one on cinematic, this one on medium, whatever, something like that. It's going to return to you if it's -1. If it's 0, that means it's low. It's 1 means medium, 2 means high, 3 epic, and 4 means cinematic. Also, you could do the same thing, like set the overall scalability. Of course, it's not going to accept -1 because -1 is custom. It could be like any combination of these here. Then but the other ones, if you, for example, pass 0 to set overall, it will be low. If you want epic, you should pass 3 here. So also, in addition to that, just like C++, you could set these one by one. Then you switch to a custom profile, like these one here exactly are the similar. For example, global illumination, shadow, post-processing, anti-aliasing, foliage, whatever. You see, you have global illumination, post-processing, reflection, whatever, you have them. Anti-aliasing, whatever. Then this is the rest of it, of course. You could do that. And also in C++, actually, you could find the equivalent function. It is called set from single quality level. If I go to my IDE, set from single quality. Yeah, it's this one. Actually, we found it. And these are equivalent of this. Like when you, for example, pass 2, 3, like this is 0, 1, 2, 3, 4. Then it's going to set all these, like these are exactly the same as this one. This is the equivalent C++. So of course, it's going to clamp it to get the correct value. Then, yeah, basically, it's the same thing. If you need to take a look at this, yeah, basically that's it. You could do this also in C++ as well. But for Blueprint, if you haven't implemented this in C++ like I did, you could use it like this. For example, when I press key 1, I get the get game user setting. Then I check if this, of course, object is valid because it could be null. Then it crashes your engine. Then I'm going to set overall scalability level to 0. And then I apply the settings. You have to do that. Otherwise, it's not going to be applied. Then also, for example, for cinematic, if I press 5, then I'm going to get user setting is valid, check, press 4, and then pass 4, and then apply the settings. For benchmarking, you could just simulate the auto, like when I press 0, I run a benchmark. This is how you run a benchmark and determine which quality is best. You get the game user setting when you press the key 0. And then here, check the object is valid. If it's valid, you are going to run a hardware benchmark, which accepts some parameters for you. For example, work scale, how much work it should do. Then the CPU magnifier, how much load it should put on the CPU and how much on the GPU. Multiplier, sorry, I said magnifier, I believe, which is wrong. Multiplier. Then basically, once the benchmark is done, you are going to apply the hardware benchmark results. Then you have to also confirm the video mode because that benchmark is going to also mess with your video settings as well. Then once that is done, you are going to apply the settings as well. That's basically what you do for the benchmark. So I already now gave you all that functionality. Yeah. And then what's this one? Oh, also we could basically because I wrote this article like 6 months ago. I wanted to release this video, but it's just always postponed, so that's why I forgot most of it. But anyway, here basically you can turn this into a function rather than for like 1, 2, 0, whatever you try to write all that code. You could just turn it into a blueprint function. Whenever you pass 0, for example, it's going to run a benchmark, as you can see here. For the other ones like 1, 2, 3, 0, it's going to set the overall scalability level and then apply the settings. This is basically all that code here, from here to here. We put it inside this function, which is nice and tidy. It's going to just accept the level. You pass 0 to 5, and based on that, it's going to run some action. And then also, of course, if you forget these numbers, what is equivalent to what, you could define an enum in Blueprint. Like, for example, you say low is 0, medium is 1, high is, for example, 2, 3, 4, whatever. And then the last one will be auto, which is benchmark, and also return 5 for custom. Then you could do that also. Then, yeah, you have to also modify your function as well. These are mostly Blueprint. I'm sure if you take a look at it, you will figure it out because it's super easy. So yeah. Then you use the function like this, which is much more simplified than the code we saw earlier. Like when you press 0, you run the benchmark, set it to auto, then 1, set it to engine scalability, second, third, fourth, fifth, whatever, cinematic. So this is exactly similar to the C++ code I wrote here, which is very similar. But anyway, then again, I ran the wrong window. Then also this one. Yeah, this is also another function. We could call it get engine scalability, which is going to return your enum to you, whether it determines it is custom or it is one of those named profiles like low, high, epic, whatever, cinematic. Yeah, this is the implementation for that function. For example, if we press P, we want to print it on the screen. If we press P, we say get the engine scalability, convert it to a string, print it. That's it. And then, yeah. And then also what you could do, basically this is the implementation for this widget I had here, which shows the frame rate and also shows the scalability settings. For example, if I'm on cinematic, it shows cinematic, also shows the FPS. How did I implement that? It's called, I believe it should be maybe here inside Blueprints UI. Yes, it's this one. Let me show it to you. Yeah, it's this one. You have the canvas panel and all the other stuff here. If you go inside the implementation, which is the graph, because UMG usually from the UMG side, you should pull the data. So I do some calculation for the frame rate, as you can see, like for example, divided by 1000 or 1 by basically the delta second, and then calculate the FPS and then assign it to that text there. And then for the other one also, I get the get game user setting, then get engine scalability and show the scalability and add it basically as a text on a screen. Here, it's very, very similar to that one, but of course, I had to adjust the other one for my own C++ API, but this is basically without my C++ API. You use the engines API to do it. So this is the code if you want to create something similar to what I created here. So that's it also. So I could just use p-printed, or I could create this widget. And then the last part. The last part is basically if none of the above works for you, there's still hope. You could use the NVIDIA DLSS technology. Basically, These three plugins I'm going to mention here. These are like upscaling technology that you could use to improve the performance and also the quality of your game. Some of them, for example, like NVIDIA DLSS requires AI chip because it requires an AI chip on your GPU. That's why, for example, NVIDIA DLSS is tied to NVIDIA hardware, and it requires, for example, at least RTX 2000 series. But like the one from AMD, which is called AMD FSR, this one could work like with even NVIDIA GTX 10 series, which is really old, or for AMD Radeon RX, for example, 400. It could work with that as well. But also there's Intel XESS, which works with any GPU, like NVIDIA, like AMD, like Intel's hardware. But overall, I believe your game should not rely on this. You should already be getting good frame rates. And then if you are getting good frame rates, you could also use this like a cherry on top and get a better performance or get a better quality. You could provide it inside your project. Of course, you could, if you have a game, you could provide it with one of these or all three. But just one more thing, for example, if you are using NVIDIA DLSS or AMD FSR or the other Intel one, as far as I know, these are not working on mobile. You have to use them on PC, like, for example, PCVR mode. If you want to use it in VR, you use it on your PC, then you stream to your headset. You cannot just deploy to Android using an APK, and then the APK, for example, uses DLSS. It is not, unfortunately, possible. But anyway, most of the games these days use this technology. That's why, I mean, I believe game development is ruined because some game devs became lazy. They rely on DLSS or AMD FSR or Intel XeSS to basically compensate for their own laziness, and that's why a lot of people complain about the quality of games decreasing. That's why I don't, as I said, your game should run fine without this, and these are like something to add to your project for improved performance. It's just that's it. So overall, this is it. I hope you've enjoyed this tutorial. This was mostly targeted at people who are beginner at optimizing Unreal Engine projects. Of course, there are more to it, and of course there are more you could always learn. And I myself even still learning how to optimize Unreal Engine project. But so far this was something I wanted to do for the past 6 months or so, but hopefully now I had the time to finish it, and I hope you've enjoyed this tutorial. And also let me know because basically for this NVIDIA DLSS, for example, I showed you in the video at the beginning. I just this is the widget that you could use, but of course you could use it programmatically from Blueprint or C++, even with this other ones. Let me know if there's a demand for it for a tutorial. I could of course create tutorials for you. So I hope you've enjoyed this tutorial, and see you on the next one.